Hi everyone, so today's lesson is on the graphs of a quadratic function in vertex form, okay? So let's actually just review what we already know about some functions. We know that a linear function is in the form f of x equals mx plus b. So that's a linear function. It could also be written in the form y equals mx plus b. And it's the graph of a line. Its graph is a line, okay? And when we talk about functions, we know that means that they have inputs and outputs. They have x's and y's, okay? And the absolute value function is something in the form f of x equals the absolute value of x. Again, it could also be written as y equals the absolute value of x. And its graph is a perfectly symmetrical V shape. We also know that the bottom of the graph is called the vertex. And we call that a minimum. It means it has a minimum value. All right, but now let's review what a quadratic function is, okay? So a quadratic function is in the form, we know that a quadratic equation or function is something where the highest exponent is 2. So the highest exponent is a 2. And we want to be able to identify our functions, what type of functions we're talking about. Now, a quadratic function can actually be written in two different forms. Standard form, or the parent function, can be written as f of x equals x squared. Standard form can be written as f of x equals ax squared plus bx plus c. So it's in descending order by exponent. C is a constant. And that's usually the form we see it in when we want to factor a quadratic. But there is another form that looks more like the absolute value function, and that's called vertex form. Okay? Vertex form. And vertex form is written in the form f of x equals a x minus h squared plus k. And it's vertex form because when we look at something that's in vertex form, we can see the vertex. The vertex, just like in the absolute value function, is hk, where we change the sign and we keep the sign. The graph of a quadratic function, I hope you know that it looks like a U shape. It's a really symmetrical U shape, like that, and it's called a parabola. Now, we're going to be looking at this in more detail in the coming days. But today we're going to learn how to graph a parabola when it's in vertex form. Okay, so first let's just look at a parabola. So here we have a function. We know it's a quadratic function, so we know that our graph should look like a U. And we're going to actually make a table of values to sketch the graph. So I'm going to make some x's and some y's. And we want to pick x's, some negatives and some positive values. So for the quadratic function, I'm going to pick -2, -1, 0, 1, and 2. So those are going to be my inputs into the function. I'm going to plug them in for x. I'm going to square each one of them, and then my output would be the y, or the f of x. So -2 squared is going to give me 4. -1 squared is going to give me 1. 0 squared is going to give me 0. 1 is going to give me 1, and 2 is going to give me 4. Now, you may notice that this has symmetry right down the point, which is actually the vertex. So I'm going to plot those points, 0, 0, 1, 1, -1, 1, and 2, 1, 2, 3, 4, and 4. And I'm going to draw a nice U shape. Now, be careful. This is not a V. This is a nice U that turns and rises as we go. Now, the domain we've talked about with a quadratic function, there are no limits on the inputs I can put into this function, so it would be all real numbers, which is -infinity to infinity. Now, the range, we always look at the y-coordinate of the vertex, and the y-coordinate of the vertex is 0, and so it includes that number, 0, and it's going all the way up along the y-axis to infinity. So that's the domain and the range. But I want you to notice that it is symmetrical right down the vertex. So there's actually a hidden line that goes down that, and that's called the axis of symmetry. And it's very similar to the axis of symmetry from an absolute value function. Now, what's important, though, is that an axis of symmetry is a vertical line. It's a vertical line. That's going to be important. All right, so when we look at the absolute or the quadratic function, if it's in vertex form, then we can change the graph. We can shift the graph. We can translate the graph the same way we did the absolute value function. For example, f of x equals x squared plus 2. So on the outside of the function, so it's not being squared, is going to move it up 2 units. So it's going to move the parent graph of f of x equals x squared. It's going to move it up 2 units. When it's on the inside of the function, meaning it is being squared, so it's attached to the x, it's going to move it to the right 2. Remember, it's always the opposite direction. If I put those pieces together, I see that this is being shifted to the right 1 and up 5. Now, you can identify the vertex in all of these. The vertex in the first one would be 0, 2. In the second one, it would be 2, 0. In the third one, it would be 1, 5. Those are the vertex of our parabolas, our new vertex. All right, in number 4, we've got that negative in front of the function, which tells me it's reflecting over the x-axis, as well as being moved to the left 4 and down 1. All right, so it's a reflect over x, and then it's moving to the left 4 and down 1. Left 4 and down 1. All right, last one, when we put that a value in front, remember that's in the place of the a. When it's greater than 1, it's a vertical stretch, so it makes it narrower. So this is going to have a vertical stretch towards the y-axis of 2. It's going to move to the right 1 and down 3. And the last one, when my a value is less than 1 but greater than 0, so it's a fraction less than 1, then it is going to be a vertical shrink. So it's going to get wider. So vertical shrink of a half. And this one, again, is moving to the right 1 as well and down 3. I think I forgot the down 3 right there. All right, so that's a little bit about translating graphs. We're going to be looking at graphs, though, a little bit more in detail and getting some more values on them. So again, to reiterate, when we see something that's in the form either y equals a, x minus h squared plus k, this is called vertex form. Vertex form. Okay? And our vertex is always going to be hk. Now remember, we change the sign of the h. So it's change, and then we keep the sign of k. The axis of symmetry is a vertical line that goes straight down the vertex. So it's always going to be a vertical line, which means it's going to have the equation x equals, okay? And because it's the x, it's going to go through the x coordinate of the vertex. It'll always be x equals whatever that x coordinate is. So in this case, x equals h. All right, y-intercept. Now, the y-intercept, important point, it's not k. To find the y-intercept, you set x equal to 0 and solve for y. You set x equal to 0 and you solve for y. Let me fix that. So you set x equal to 0 and solve for y. All right, then I'm going to show you how we can find a symmetry point. Okay, we're going to reflect the y-intercept over the axis of symmetry, and I'm going to show you how to do that. And then we really want to make sure that we always explain the translation of the graph, meaning, is it a vertical shrink or stretch? We get that from the absolute value of whatever the a value is. Does it reflect? Meaning, is there a negative in front of the a? And then the hk change, okay? All right, the domain, again, we've talked about this regularly. There's no limit as to what you're allowed to input into the equation. So the x's are unlimited, which means all real numbers. We write that as negative infinity to infinity. And the range, we always look at the y coordinate of the vertex. So it's either k to infinity. If it opens down, it's going to be negative infinity all the way to k. and hard bracket because it will include that y coordinate of the vertex. All right, let's try one, okay? All right, so on the one on the right, we first look at it and we identify the vertex. So the vertex is in the location of h and k, so it's going to be 1, 8. The coordinate point 1, 8. I'm going to go to the coordinate point 1, 8, so 1, 2, 3, 4, 5. Actually, you know what? I'm going to change the scale to 2. Sorry about that, guys. So I'm going to make each one of these equal to 2. All right, so that's going to give me 1, which is going to be in the middle, and then 8 would be 2, 4, 6, 8. And there would be my vertex. And I'm actually going to put a V there for myself so I don't forget. The axis of symmetry then would be a vertical line going through that point, so x equals 1. To find the y-intercept, I'm going to set x equal to 0 and solve for y. So y equals 3 times 0 minus 1 squared, don't forget the squared, plus 8. All right, so then I do y equals 3 times 1, negative 1 squared is 1, plus 8. And I get y equals 3 plus 8, which is 11. I write it as a coordinate point, so 0, 11. Okay, so I go up to 11. So this was 8, and this would be 10, so 11 would be right about here. All right, now I need to use the symmetry and the line. So I'm actually going to take this, and let me make it thinner. I'm going to draw in my axis of symmetry, going right down the vertex. So it's going right down the middle, so 1. So to reflect that point, I want to reflect the y-intercept. I go the same distance on the other side of the y-intercept, which would be right here, which would be at the point 2, 11. Noticing they're the exact same distance from the y-intercept, from the axis of symmetry. From 0 to 1 is 1 unit, and from 1 to 2 is 1 unit. So I'll always be the same distance on the left and the right. Now I can see that it's a very narrow parabola, which holds true because that 3 in front of that A term is a 3, which makes it a vertical stretch. And so then I make a parabola going like that. Okay? All right, so my translation to the parent graph is that it's a vertical stretch of 3, which makes it narrower. It goes to the right 1 and up 3. My domain, negative infinity to infinity. And my range, I start at the y coordinate of the vertex, so 8, and I go towards infinity. And again, it's a parabola because it's a quadratic function, and that is the graph of a quadratic function. All right, let's try one more, okay? All right, so this one's a little bit different. I have a negative in front of it, so I already know it's going to reflect over the x-axis. I'm actually going to write that down for myself. I see that it's 1/2, that a is 1/2, the absolute value is 1/2, so then I know that it's going to be a shrink. So a vertical shrink of 1/2, which means it's going to be wider than the parent function, and that it's moving to the left 3 and up 4. All right, so let me get started. Let's get started with our vertex. Remember, our vertex is the HK, so it would be negative 3, 4, and remember that we always change the sign. The axis of symmetry is a vertical line going right through the x coordinate, so it would be x equals negative 3. The y-intercept, we set x equal to 0, and we solve for y, making sure when we write it in that we don't forget the square part. All right, so I'm going to simplify that. I get 3 squared, which is 9, and then 9 times negative 1/2 gives me negative 9/2 plus 4. Negative 9/2, I'm going to get a common denominator, so I'm going to multiply this side by 2 over 2, which is 8/2. And so I get a negative 9/2 plus 8/2, which gives me negative 1/2. Okay, so my y-intercept then is 0, negative 1/2. All right, I'm going to plot the points I have so far. So I've got a vertex of negative 3, 4, 1, 2, 3, and then 1, 2, 3, 4. So there's my vertex. Put a V for myself. I have an x-intercept of 0, negative 1/2. So right about here, there's my y-intercept. I'm going to draw in my axis of symmetry. So there's my line going straight down the vertex. Okay, and I'm going to notice that from the axis of symmetry, that y-intercept is 3 units to the right, so I need to go 3 units to the left. So 1, 2, 3, also at a half. That would put me at -6 1/2. -1/2, sorry. -6, -1/2. And now I'm ready to draw my parabola. Making sure that it's a nice U shape and not a V, and it crosses like that. I know it's not perfect. My domain, again, there's no limit as to what x value I'm allowed to plug in as an input to the function, but my outputs are always going to be from that maxima or that vertex going down in this case. So -infinity all the way until I get to that vertex, that y-coordinate of 4, and it's a hard bracket. All right, so that should have been 2 great examples for you. So I'd like you to go ahead and try example 2, and we'll go over it in class tomorrow. You also need to watch video 2 once you've done that. So do the graph and then go on to the short video 2. Have a great day, guys.